Hi, I'm Dr. Charles Harry, and welcome back to Cybersecurity for Everyone. In our last episode, we introduced the idea of encapsulation, this notion that in order to move data from one part of the earth to the next, we had to include a bunch of instructions together in order for applications to understand how to work, how networks can route with one another, and how the physical mediums can transmit that energy. We introduced the concept of the OSI model. And if you recall, we talked about 7 different layers. And in today's episode, I want to specifically talk about the application layer. So when we use an application, whether it's you're talking about an email client or your web browser, applications will have their data packaged and tagged with instructions so that the recipient system understands what to do with it. Those instructions are interpreted by that recipient's application and eventually are displayed to them. The application layer, therefore, acts as an interface between your computer and the programs on it and the network you want to communicate on. Lots and lots of instructions exist on the application layer. So, there are different examples of different types of applications and different sets of protocols that we might find. Remember, protocols are just simply instructions. We might have instructions related to how to transfer files, or how to manage the network at the app layer, how to manage domain names, browsers, even remote logon and email. These are just examples of the different types of instructions that occur at the application layer. So, in this particular episode, I want to talk a little bit more about just one of these, the domain name management system. And I want to give basically a very simple set of examples of how this actually works. So let's talk a little bit about a website address. When you use a web browser, you're allowing a user to either send or receive information in a very visual manner. Now think about it. When you get on a web browser and you go to a search engine like google.com, or it could be Bing or any of your other favorite search engines, you are visually interacting with that web content. But the question is, how does the computer know where to go to actually request that information? It's not like Google or Microsoft has all their computers in your house. They're hosting all those websites somewhere in a different part of the world. So how does your computer actually know where to go? It's probably something that a lot of us don't really think about all that much. So a computer needs to translate a human-friendly term like Google or Bing into something that it actually understands. Something we call an IP address. Now we'll talk more about IP addresses in the next episode. But it's enough to understand that in order for us to be able to actually send and or receive web content, we need to translate a human-friendly term like Google into a value that a computer actually understands, in this case, an Internet Protocol address. So how do we go from google.com to something that the computer actually recognizes? And we use something called the Domain Name Service, or DNS. So think of DNS as the phone book of the internet. Basically, it's a set of lists that pair names like google.com with a value that the computer understands, in this case, an Internet Protocol address. The computer retrieves that Internet Protocol address so humans actually don't have to memorize it. You can imagine, with the millions and millions of websites that exist on the internet today, if you had to memorize all of those website addresses, good luck. It just wouldn't happen. So DNS is actually a really, really helpful service to be able to allow us to do this simple translation. So the goal of DNS is to find out where on the internet to establish that connection. So if I have this large set of independent, interconnected networks, how do I know where to go? So in order to find google.com, our computer first needs to find the right telephone book. And once they've found that right telephone book, because there's different versions of it, then they can find the right entry. And only then can it return the right Internet Protocol address that pairs with google.com. And there really are 4 components to the DNS system. There's your what's called a local DNS server, a root DNS server, a TLD or a top-level domain DNS server, and an authoritative DNS server. So let's kind of walk through how this actually works. And we want to start off with our own PC. So your PC is interacting with a local DNS. And the local DNS is in essence acting as a middle person. It is doing the translation and the work with the root DNS and the TLD DNS and the authoritative DNS in order to get the right Internet Protocol address. So the local DNS server first reaches out to the root DNS server. And it's really all about, okay, who actually knows about .com? Because there are actually a variety of different root DNSs. There's .com, .edu, .net. You've heard about a lot of these. So we got to find the right telephone book. So who knows about .com? And the root DNS then will respond back to your local DNS server with that information. It says, if you're interested in .com, this is where you need to go. The local DNS server will then reach out to the top-level domain DNS server. It says, all right, I'm in the right place. I'm in the right building, or I'm in the right shelf of books. Who knows about google.com? It returns that value back to the DNS, the local DNS server. Then that local DNS server reaches out to the authoritative DNS server and says, okay, I'm in the right place. Tell me where google.com is. And it says, I know where google.com is. It's at 8.8.8.8. And it returns that value back to the local DNS server. The local DNS server is now armed with the information it was seeking. And it returns that information back to your PC. So when you register a domain name like google.com, that namespace, that value that you're looking to register is actually managed by an organization. That organization is known as the Internet Corporation for Assigned Names and Numbers, or ICANN. Those root zones are geographically distributed, and the location of those TLD DNS servers are managed by those specifically geographically focused institutions. So why does this matter? Why are we talking about this? Well, the problem is, as we discussed in our last episode, is that vulnerabilities exist in several of these protocols. So at the application layer, there are some vulnerabilities in how those instructions are actually executed. And it's those vulnerabilities that are used by hackers to gain access to achieve some level of effect. Software developers who are not careful in the design of their software might introduce new vectors of attack. Network administrators who leave vulnerabilities in their systems might also introduce new attack vectors. So we need to understand not only how data moves, but the instructions associated with every single layer in that OSI stack. Because if you don't, you may miss certain vulnerabilities that exist. So what do we want to take away from this episode? So how information is translated and how that information then interacts with the network is done at the app layer or the application layer. Translating human-friendly domain names like google.com into something that a computer understands, like an Internet Protocol address, is done by something called DNS, or the DNS protocol. In our next episode, we're going to talk about the network layer and how data is actually routed on the internet. I hope to see you next time.